Greetings and welcome to the Introduction to Astronomy. In this episode of Special Topics in Astronomy, we will explore hydrostatic equilibrium and discover why stars do not collapse under their own gravity. So let's get started. Why don't stars collapse under their own gravity? Gravity is constantly pulling every part of a star inward. If gravity acted alone, it would continue collapsing toward its center. But stars remain remarkably stable for millions or even billions of years. A reason is the delicate balance between gravity pulling inward and pressure pushing outward. Astronomers call this balance hydrostatic equilibrium. Gravity tries to compress the star, increasing the pressure deep inside its interior. That pressure comes from the hot gas within the star, which pushes outward in every direction. As long as these two opposing effects remain balanced, the star neither collapses nor expands dramatically. Hydrostatic equilibrium is not a one-time event. It is a continuous balance that allows a star to maintain its size and structure throughout most of its lifetime. Rather than thinking about the entire star, imagine focusing on just one thin layer inside it. Gravity from the layer above presses downward on that shell. At the same time, the hotter, denser gas beneath it pushes upward. If gravity became stronger than the pressure below, the layer would move inward. If the pressure became greater than gravity, the layer would expand outward. That same balance exists throughout the entire star, from its outer layers all the way to its core. Hydrostatic equilibrium is not unique to stars like our Sun. It governs every stable star throughout the universe. In stars like the Sun, ordinary gas pressure supports the star against gravity. Red giants are also supported primarily by gas pressure, although their interiors have changed dramatically. White dwarfs survive because electron degeneracy pressure resists further collapse. Neutron stars rely on even more extreme neutron degeneracy pressure. Although the source of the pressure changes, the principle never does. Every stable star exists because gravity and pressure remain in balance. Hydrostatic equilibrium is one of the fundamental ideas of stellar astronomy. It determines the size, structure, and stability of stars throughout their lives. As stars evolve, the source of the supporting pressure may change, but the balance itself remains essential. Without hydrostatic equilibrium, stars could not exist in the stable forms we observe throughout the universe. Hydrostatic equilibrium reminds us that stars are not static objects resisting gravity. They are dynamic systems that continually balance gravity against pressure, layer by layer. By understanding that balance, astronomers can explain how stars remain stable, how they evolve, and why the same physical principle applies throughout stellar evolution. So that concludes our discussion on hydrostatic equilibrium. We'll be back again next time for another episode of Special Topics in Astronomy. So until then, have a great day, everyone, and I will see you in class.